Hey everyone, welcome back to From YAML to Production, a Kubernetes podcast. I'm Maria, and today again we have our tech host Hristo with me here. In the previous episode, we covered Kubernetes fundamentals, pods, networking, and deployments. Today we are moving to the next layer, how a Kubernetes cluster is actually built and configured.
Hey Maria, hey everyone. In this episode, we will cover Kubernetes cluster architecture, infrastructure preparation, and installation at the high level. Once we understand how a cluster is assembled, it becomes much easier to operate and troubleshoot in production. For a deeper step-by-step breakdown, you can find the full blog article linked in the video description.
So this is about the system behind Kubernetes, not just using it, but setting it up correctly.
Exactly, Maria. Think of it as understanding the platform itself, not just the workloads running on it.
We already covered what control plane and worker nodes are in our first series, the modern software development, but can you please remind us what happens inside the cluster at that level?
So, Maria, at the high level, the control plane is responsible for decisions and coordination, while worker nodes run the workloads, right? The control plane includes the API server, which is the entry point for all the operations. Every configuration change or deployment request goes through it.
And etcd is part of the control plane.
Yeah, Maria. So etcd stores the cluster state, what should be running and what currently exists. It's the source of truth. If etcd, for example, is lost without backup, rebuilding the cluster becomes very difficult.
What manages the workload placement?
Think that the scheduler assigns pods to nodes based on the available resources and constraints. Then the control manager, so-called, continuously checks what's the actual state that matches the desired state. If something fails, controllers recreate or adjust resources to maintain availability.
And on the worker nodes?
Each worker runs a kubelet, which communicates with the control plane and ensures that pods run correctly. Container runtime handles the containers, and kubeproxy manages service networking so pods can communicate.
So the control plane defines and monitors while the workers execute.
Correct, Maria. In production, you usually run multiple control plane nodes to avoid a single point of failure and to maintain availability.
Before we move into installation, what architectural decisions should be made first?
The main ones are availability, scaling, and where the cluster will run, Maria. For testing, a single control plane is enough. In production, clusters usually run multiple control plane nodes to avoid a single point of failure and keep the API available, as we said.
So high availability is planned up front. So how do teams approach scaling and cluster model choices?
You define how the cluster scales. Some setups use fewer, larger nodes for simplicity. Others use smaller nodes and scale horizontally. Kubernetes supports both, but the choice affects resilience and scheduling. Another decision is managed versus self-managed Kubernetes. Managed Kubernetes platforms reduce operational overhead, while the self-managed clusters provide more control but require more responsibility. For more details about managed Kubernetes services, please check our previous episodes.
Can you tell us when multi-cluster designs come into play?
As platform grows. So separate clusters, we can separate clusters for environments or regions, improve isolation and reliability. Multi-cluster setups add complexity but are common at scale.
So these choices guide everything that follows.
Exactly. Once availability, scaling, and cluster model are defined, installation becomes much more predictable.
Before installing Kubernetes, what needs to be prepared on the servers?
Um, Consistency across nodes is critical, Maria. Host names and DNS must resolve correctly so nodes can communicate reliably. Time synchronization is also important because certificates and walks depend on the accurate clocks.
What about system configurations?
Swap should be disabled because Kubernetes expects predictable memory behavior. Kernel networking settings must allow proper packet forwarding. You also need a clear plan for pod and service network ranges before installation.
So the networking design happens early.
Yes, Maria, choosing a networking plugin and defining IP ranges directly affects performance, security, and observability. These decisions shape how traffic flows inside your cluster, um, how policies are enforced, and how easily you can monitor and troubleshoot workloads. Taking the time to design your cluster networking properly pays off in long term. Storage architecture and node roles should also be defined earlier in the planning phase, not deciding during the installation. In the next article, in episode 3, we'll take a deeper look at the Kubernetes storage and how to design it for the real production workloads.
Once the infrastructure is ready, how is the cluster installed?
A common method is Kubeadm. You initialize the first control plane node, which setups core components and certificates. After that, you configure access from your workstation and install the networking layer so pods can communicate.
So then the worker nodes join.
Yes, Maria. So workers join the cluster using a secure token and become available for scheduling workloads. For production environments, additional control plane nodes are added behind a load balancer to provide high availability. In managed Kubernetes services such as Amazon EKC, Azure Kubernetes Services, or Google Kubernetes Engine, much of those processes are abstracted away. The cloud provider provision and managed the control plane for you, including upgrades, high availability, and etc management. You are primarily responsible for worker nodes and workload configuration. However, even in managed environments, understanding the underlying installation sequence is critical. When something breaks, the abstraction disappears quickly, and knowing how control plane components, networking, and node registration work becomes invaluable.
So the installation follows a defined order. First the control plane, networking, and then the workers.
Exactly, Maria. So each step builds on the previous one, and validating along the way helps ensure a stable cluster.
Thank you, Hristo. This makes Kubernetes cluster feel tangible, not just concepts, but systems that can deliberately be designed and operated.
That's the goal. A solid understanding of architecture and installation lays the foundation of everything that runs on top. You can find a more detailed breakthrough, including diagrams and accompanying Medium article linked in the show notes, Maria.
This was from Yamamoto Production, a Kubernetes podcast. If you found this discussion helpful or valuable, please consider subscribing and sharing it.
Until next time. Bye-bye, everybody.
Bye.